Welcome everyone to our Alfasoft online demo days. And thank you for joining us for today's webinars. My name is Torgrim Sandvold, and I'm the product manager for statistics and data analysis tools here at the Norwegian office of Alfasoft. In the next webinar, we will be presenting the statistical package R, and the presentation will be given by Måns Tullin from the Swedish company Statistikakademien, who offers training in R and also other statistical packages. But before we start, just a little housekeeping. If you have any questions during the presentation, please type them into the question box in the GoToWebinar panel on your right. We will try to answer them during the presentation, and hopefully we will also have time for questions at the end. You will all be muted during the presentation to avoid any audio problems. And please note that we will be recording this webinar, and both the recording and questions from this session will be answered and made available to you afterwards. Hopefully, we will have this published and ready for you by next week. With that, I will hand over the screen to you, Måns. So let's see here.
Very good, thank you.
Great, good luck with your presentation.
Thanks. And as you've now heard, my name is Måns Tullin. I'm a statistician. My background is in academia. I did my PhD in mathematical statistics at Uppsala University in Sweden, and I still live in Uppsala. These days, I mainly work as a consultant through Statistikakademien. We do statistical consulting, but also mainly we teach courses on statistical software, including R, which is what I'm going to talk about today. So I'm going to start out today by saying a few words about R, what I think makes R special, and then introduce some courses that we teach in R, and then I'll give you a demo of R's capabilities for visualization and regression modeling, reproducible science, and more. But let's begin from the beginning and answer the question, what is R? So R is a statistical programming language, which means that it can be used for programming, but it's tailored for statistical analysis. And that means that it covers the different things you need to do when you work with data and statistics. So it contains tools for data wrangling, by which I mean merging your data, transforming your data, filtering your data, and all those sort of manipulations that you need to do with your data in order to get it in a format where you can analyze it. It also contains a lot of tools for visualization. So that's plotting your data and exploring your data, and just looking at your data to get a feel for it, or to show it to others, or to generate hypotheses. And finally, of course, it contains a lot of tools for statistical analysis, whether you want to do hypothesis tests or fit some kind of models like regression models, if you want to do the really modern, in vogue stuff like machine learning and AI, R has capabilities for that as well. So it's a general statistical toolbox, which makes it possible to do basically everything that you want to do within the field of data analysis and statistics. It has had a reputation for being the new kid on the block, the new thing in statistics R, but I guess that's no longer true. It's been around since the year 2000, so it's now 21 years old. And at this point, it's a well-established, well-tested, and stable statistical software that's used worldwide by thousands of users, or I should say hundreds of thousands and millions even. In terms of software, R is the programming language, and you can use different softwares for writing and running R code. The most common one being RStudio, which I'm going to demo later today. The software that we use to run R is called RStudio, and that's separate from the R programming language, but usually you don't see that difference. So you can always ask, of course, with any statistical software, why would I use that particular software? One reason that people like R is that it's free and open source, so it's easy to get started. The reason that I use R as a statistician, as someone who does data analysis all day long, is that it gives me a lot of flexibility and control. Compared to other software packages, it has more methods and better methods. The reason is that statisticians worldwide, including academic statisticians, the people who develop new statistical methods, all use R. That means that when a new method is published, someone writes an add-on package for R for that method. Usually the researcher who invented the method. They write an add-on package for R that adds that method to R. And in fact, there are more than 17,000 such add-on packages. So as you can imagine, there are just so many methods available, so many tools for different types of data, for different fields of applications, and for different kinds of statistical problems. So anything that you want to do, you can do, because there are just so many different methods available. You're not limited by the methods that happen to be available in a menu. There are no limits. Anything is possible. And if a method doesn't exist, it's possible to write your own code to make it exist in R, to implement it. Another good reason to use R in research, I think, is that it increases reproducibility. The fact that you're writing code to run your analysis means that it's easy to repeat an analysis if you need to run it again to check something, or if you need to change something. Maybe there was some change in your data, a patient in your data set needed to be removed, or maybe you need to rerun the analysis under slightly different conditions because a reviewer asked you to do that. If your analysis is based on code, that means that you can run it again because you have that same code, it still works, and you don't have to click in all those menus and find out how you did the analysis once again. This also makes it easy to share analysis with collaborators, with people interested in your research, or just as an appendix to a paper, to really make your research open and reproducible. Okay, so those are some of my ideas about why R is useful and good. It's very flexible and gives you a lot of control, and it's also good for open science. Let's see. There we are. So, Statistikakademin, we offer online courses on statistics with R. These are teacher-led online courses, 1 day each, in which we try to give intuitive explanation of modern statistical methods. And I want to stress this. We're talking about modern statistics here. We want to do things in a modern way using computational power. We don't want to necessarily have to rely on mathematics from the 1920s, which is what you get in a lot of introductory courses on statistics. We want to make use of the fact that R is a modern software for statistics, and really use the best methods available today. Courses design, or these courses are designed, gives you lots of hands-on time with R. The best way to learn R is to work with R. So when we run these, we want you to work as much as possible with R. So there are tons of exercises that you work with. There are examples that you run and work with explanations, and all the exercises have fully worked solutions, so you don't need to get stuck anywhere. You can always see how we solve them. In addition to that, the teacher is there to discuss any questions you have and so on, and also gives lectures where we explain the different methods and demo examples with R to show you how things are done. So lots of teacher-led time, but also lots of hands-on time with R, where you can work with problems on your own and learn the language by using the language. Most of these courses are based in part on a book I've written called Modern Statistics with R, which was published this year. That book assumes a stronger background in programming and in statistics than what we do for these courses, which are meant for as introductory courses for researchers working in other fields, also for companies and government agencies and so on. So people who need to do statistical analysis, but aren't necessarily statisticians or programmers. So we've tailored the materials from that book to work for that audience instead. But other than that, the book is similar in scope and in style to these exercises. It's freely available online, so you can have a look at that to get a feel for what the material that you'll be working with in the courses looks like. So that's modernstatisticswithR.com, where you can find that book. We have let's see if I can change pages. Yes, great. We have 5 of these courses. We call them R1, R2, and so on. And R1 is our introductory course, which has no prerequisites. You should be able to use a computer, and that's it. You don't need to know programming. You don't need to know much statistics. It's an introduction to R, which will show you how to do some basic statistical analysis, how to import data, how to modify your data, and so on. We run this maybe 6 times a year. You can see some of the next dates here. It's December, for instance. So that course is a prerequisite for the other courses, because you need to know the basics of R in order to do anything else. But other than that, the other courses are fairly independent. Our R2 course covers linear models, linear regression, ANOVA, and we focus a lot on non-normal data, which I'll get back to later today. R3 is more advanced regression models, mixed models, survival analysis, logistic regression, that sort of thing. Our R4 course covers visualization and data exploration, and we really go into depth about how to create great looking graphics and how to use statistical graphics to explore your data and visualize things that are happening in your data. Then R5 is our course on observational studies, which are common, for instance, in medicine, and propensity score matching for creating matched samples from huge databases, for instance. Okay, we've been running these courses online now for 1.5 years and have had some excellent reviews throughout, which we, of course, are very happy about. And if you want to learn more about these courses, we will send you the slides from this presentation after I finished, basically, where there also are some pages which list more in detail the contents of these different courses. Okay, but I don't want to spend this entire hour just doing marketing. I want to show you R instead. So I'll switch now to RStudio, the software used for running R analysis, and start by looking at some examples. So the idea here is not really that you should be able to write a lot of R code after you watch this, of course not. But the idea is that you'll see what R code looks like and how we work with this software. And everything that I do here is something that we do in the different courses. So if this seems interesting to you, then maybe those courses will interest you as well. So the RStudio software looks like this. It has 4 panels that offer different things during different parts of your work. In the upper left corner here is what I like to call the script panel, which is where you write your R code. So here I will write, in a few minutes, write some R code, and I can play around with that. I can change things. The code won't actually run until I click this run button. So you can play around with that and do whatever you like with your code and just prepare it. Eventually, you're going to want to run some code. So maybe I want to do a calculation like 1 + 1. I can then highlight that code and click run. The code is sent to the bottom panel here, called the console panel, where the output, so the answer from my calculation, is printed. So the console is where the code is run, where things happen, and you get the output. And the script window is where you write your code, and you can then save it and use it again later. In addition to these 2 panels, there are 2 other panels here. One is called the environment panel, which shows you the data sets that you've loaded. So in this case, I've loaded 3 data sets. One is called diamonds. It says here that it contains some 54,000 observations of 10 different variables. If I want to have a look at this, I can click on the name of the table, and it'll open looking sort of like an Excel spreadsheet. So I can have a peek at my data and look around and see what it looks like. I also have 2 other data sets loaded here. You can load as many as your computer's memory will allow. You can work with all of them at the same time. There are no limitations like that. And finally, in the lower right corner, there is the plots window where all the plots that we create will show up. And you can, if you like, change the size of these windows, for instance, if you want the plot to be larger. And we're going to do that in a few minutes as well. Okay, so the first thing you need to do when you want to analyze your data, of course, is to load your data. You can do that using code, but if you don't feel comfortable doing a lot of programming, RStudio also helps you do these things. So for instance, here there's a button called Import Datasets, which I can click, which will allow me to import data from different formats, from text files, Excel spreadsheets, SPSS data, and so on. I'm going to open an Excel file here, and I'll click Browse, which will let me select what file to use. The file I use is called Estates. So this describes housing prices for houses sold in Uppsala 10 years ago. So it describes what price the house was sold for, and then some information about the house, like what was the living area, the supplemental area of the house, what year was it built, and so on. So when I load this file, I'm given a preview here that shows me what the data looks like, so I can check that it's been imported correctly. I then also get the code I can use to run this. So RStudio creates the code for me. I don't have to memorize the code for importing this data, which I can then copy and use again in the future. I now click Import, and the data set is imported. I now see it here in my environment, meaning that this data now has been loaded into R, and I can use it for my analysis as I need. Okay, I'm going to paste the code I copied here just to make sure that we see, so we can rerun this again. If I now close R and open it again, the data won't be loaded, but I have the code now that I can run to load it. So the estates data contain a few different variables, as I said, like what price a house was sold for and how large it was, the living area of the house. And I want to create some graphics that describe this, that help me understand what the data look like. So in order to do that, I'm going to load some packages that help me create good looking plots in R. And we teach these in our courses as well, particularly the so-called ggplot2 package, which is used to create really good looking plots. So I will run this code here, which says that we should go to the library of packages and open these packages. So I highlight that and click Run. It's sent to the console, and these packages are now loaded, so I can use them and use all the functions available from them. What I'm going to do is that I'm going to create a plot where I want to see the association between the living area of the house and what price it's sold for. So create a plot. I write these comments with this hashtag symbol just to make it easier for me as a human reader to read the code. R ignores those, but it helps me understand the code when I look back at it a week from now or a year from now. So I write these comments just to explain what's going on. Now, I'm not going to go into details now about the syntax for creating a plot. I use a function that's called ggplot. And I then have to specify what data set to use. My data set is called estates. I can see the name here in the environment. And then specify what variables to use in my plot. So along the x-axis, I would like to use a variable that's called living area. That was the size of the house. So the estates data contain information about the selling price and the living area, for instance, of a house, and also information about the location. Is it in the countryside, in the suburbs, or in the city? So I'm going to use those three variables to create a plot and see if there are any interesting patterns that emerge. So along the x-axis, I want this living area variable. Along the y-axis, I want the selling price of the house. And the beautiful thing about these plots is that you build them sequentially. You build them part by part. So if I just run this code here, the only thing that will happen is that I'll generate a coordinate system, and there's still nothing in it. Along the axis is the living area, along the y-axis is the selling price, and it still doesn't contain any information, right? But then I can start adding things to my plot, like adding points that represent the different houses in the data set. So I'll add a plus sign here, and on a new row, I write G on point, which means that I want to add points, and what I just created here. Now when I run this, each house in the data set is represented by a point. And I can then play around with the settings here if I like. Maybe I want the points to be larger. I can then change the size of the points. Maybe I want them to be a little bit see-through because some of them are overlapping. So I can change the opacity of the points using a parameter called alpha. And I click run and run this again. And now I have slightly larger points that are slightly see-through. If I wanted to, I could make them even more see-through like this to really show where there are overlapping points, because those will become darker because of the overlapping areas. And then I can continue to add things to this plot. Maybe I want the different locations, the city, the suburbs, and the countryside, to be represented by different colors in this plot, for instance. I could then add another argument to this, where I specify that the color of the point should be determined by the location variable, which describes the location of these. I then click run, and the plot is updated, including this information about these 3 different categories, which makes it easier to compare these groups. We immediately see that the selling price of houses on the countryside, these green points, appear to be lower than in the suburbs and in the city. So it's fairly straightforward to keep adding things to your plot like this. There are lots of things you could add. You could maybe add some new labels for your axis, a new X label that says that this is the living area in square meters, for instance. Or you could add a Y label, a label for Y-axis that says that this is the selling price in thousands of Swedish krona. Maybe you want to add a title to this as well. So Uppsala housing prices, for instance. So you can keep adding things to your plot. I run this code and all of these things are added. You can do it sequentially. You don't have to do it all at once. You can remove things if you didn't like them. And it's fairly straightforward to keep adding things like this. And there are lots of things that you could add and change if you wanted to. There are built-in themes for changing the appearance of your plot. So if you have some default theme that you want to use, you always want your plots to look in a particular way. You can use that as well. For instance, maybe you work at, I don't know, the Wall Street Journal, and you want to use the default Wall Street Journal theme that they created. Then you can use that, and your plot will always look like it's from the Wall Street Journal, and so on. So you can create lots of custom themes and play around with a lot of different settings here. Maybe you don't.
Sorry, Måns, just a question from the attendee, Fredrik. Is R case sensitive, the variable definitions?
Yes, thanks for asking that, because that's an important point here, actually. R is a programming language, and that means that it's super sensitive to spelling and capital letters and so on. So it is case sensitive. If I were to write living area with a capital L here, for instance, I would get an error message. Let's try that. So now I get some error message here in my console window. It can't find the object living area because there is no variable called living area with a capital L. So I have to be careful with spelling and so on. And this can be a bit confusing if you're used to, using Google, and you can misspell things and still find the right thing. But in R, you have to really make sure that your spelling is perfect, and that you make sure to use capital letters only when there are capital letters and so on.
Okay, thank you, Måns.
So you can play around with lots of different colors, lots of different settings, and create the same plot in many different ways. Here's another example, another default theme that you could use if you wanted to. And of course, change the colors of the points and all the text and everything here. So the point is that you can keep adding things to your plot. And if you wanted to add something else, you add it on a new row, and that way you can sequentially build your plot, which makes this quite flexible. If you wanted to create some other kind of plot, you would do that in essentially the same way. So maybe you want to plot the distribution of selling prices. In that case, we still want to use the estates data. And along the x-axis, I would like the selling price of a house. And I would like different colors to show the different locations. Then I want a density plot to show what this looks like. Actually, let me write it like that. And when I run that code, a new plot is created showing the distribution of selling prices in these 3 locations. So each of these curves shows the distribution of a different location. And you'll notice that they are overlapping, so probably it's a good idea to change the opacity of these, make them slightly see-through so that you can see what's beneath the curve that's on top. You can play around with the settings once again. If I wanted to, add a label to the x-axis, then I can do that in the same way. So these are always built in the same way. Once you get used to it, it's fast and easy to create figures like these. Usually people find them to be quite good looking and find the defaults here to be good looking as well. Now, you can of course continue like this. There are so many different graphics that we could have a look at. I'm not going to show you all of them, of course, but the point is that you can build these through code, stage or step by step, and it's always done in the same way. So if I want to create a plot that looks like this, what I typically would do is that I would, if I don't remember how to write that code, I would go back to some code I wrote previously for creating a plot like this, or I look at the materials from our courses where we show examples of how to create different plots, and I would just copy that and then replace the name of the data set with my data set, replace the name of the variables with my variable names, and then I can create this really fast, and I'll make good looking graphics in no time. Of course, if you want, you can export these, save them as PDF files or image files or whatever you like.
Sorry, Måns, can I ask you one more question?
Yes, please.
There's a question here from Cecilia about the options for the function as you write the code. Are there any, are there any auto suggestion, and where do you find the options for the functions?
Yeah. So we cover a lot of these in our courses just to show you the different things that are possible. In the plots panel here, there's also a help tab where you can search for the name of a function. So if I want to know more about this geom density function that I used, I can search for that name. It will give me a description of what this does, and then it'll give me a long list of all these settings or arguments and describe how to use them. So there is extensive help available that describes all the different settings that you can use. And there are lots of them.
Okay, thank you.
Okay, well, there's so much more we could do here. I'm not going to show you everything, of course. I want to move on to show you some other things as well. But the point is that it's fast and flexible to create good looking graphics this way that are reproducible. You can do the same thing again if you want to without having to click in lots of different menus and change lots of different settings. Because this is done in code, it will be saved automatically and you can go back to it as needed. Now, I can also use these arrows to navigate back to plots I created previously, like the Uppsala housing prices, for instance. And maybe I want to explore this relationship that I found a bit more, the relationship between the living area of a house and the selling price. And one way to do that would be through a linear regression model. So I'm not going to go through the details about what that is. If you don't know, it's a model that describes the relationship between these two variables. But I'm going to show you how this is done in R and just some nice features related to linear regression models. So I've already prepared some code for that. In this case, I'm going to remove some missing values from the data. Just for the sake of this example, that's not something that I recommend always doing in general. So after that, there are 308 observations remaining in my data set. Then I'm going to fit a simple linear regression model to my data, which is done using a function that's called ln. I'm then going to save those results as a new object called n. So this arrow here means that I want to save what's happening on the right-hand side here in an object with the name n. So I write down the formula here. I want to know how the selling price depends on the living area using the data set estates. So I run this, and R fits a linear regression model to my data. Doesn't print anything yet, but I want to print now a model summary that describes the outcome here, shows me the results. What does the fitted regression model look like? And running that, I get some printed output here in the console window. It gives me lots of information about my regression model. It tells me about the residuals, the R-squared value, F statistic, and lots of different things that you use in regression modeling. But most important thing probably is this table of coefficients. It's not super nicely formatted, but as we'll see later, you can get nice formatting. When you want to save these results, it gives me all the different information about the regression model, the beta coefficients, the estimated coefficients of the models, p-values, and so on. So it has lots of information available to us right away. Now, I could also, if I wanted to plot this fitted model, basically add the fitted model to this figure. So I'll do just that to show you what it looks like. So here are the points without the different labels. And the red line then is a fitted model that describes this relationship, which seems to imply that with greater living area, the housing prices increase, as you would expect. Now, if we were to fit a more complicated linear regression model, we could do that similarly. We use the same syntax, the same function ln for linear model. I specify what my response variable is, and then I add the different variables that I want to include in my model, like the living area, the location of the house, and maybe also an interaction between the location and the living area. I can then fit that model, print the results, and it gives me a table of coefficients. R automatically handles the fact that location was a categorical variable. It creates dummy variables for me and does all the heavy lifting in fitting this model. You then have to know how to interpret the coefficients, of course, and that's something that we discuss in detail in our courses on regression. But that's not really what I wanted to show you. If you work with regression models like this, you know that you're supposed to look at the residuals and see if they follow a normal distribution and do what I call model diagnostics. That's fairly straightforward to do in R. There's a function called autoplot that will create lots of useful model diagnostics plots for us. I'm going to run that. And it then shows me some plots describing the model fit. You can learn about how to interpret these. They show different things, different conditions that are assumed in this linear regression model, and shows you outliers and things like that in different ways. So these are really useful plots for analyzing your regression model. One of the things that you see is a normal QQ plot, which tells you whether or not your residuals follow a normal distribution. If they don't, well, then typically you would be advised to maybe transform your data or do something else with it. But that's not really necessary. As I said, R is a modern statistical language. It has all the modern methods. And of course, it has methods for doing regression with non-normal data as well, and for getting p-values with non-normal data. And it's just as easy as getting p-values and stuff that's based on the normal distribution. It's no more work for you. So why not use those methods instead of worrying about whether or not you have a normal distribution? So we can get, for instance, p-values for our regression model, even if we have non-normal data, using a method called the bootstrap. I'm going to run this here. Takes a few seconds, and then it produces a table of results. Let's see if I can. Now the window is too small, so the table is on 2 rows. But anyway, it does give me bootstrap confidence intervals and p-values for all the different coefficients involved here. You see that some of the p-values are very low, whereas some are not as low. Point is that if you're using modern statistics, you don't have to worry about all these things that you traditionally worry about in statistics, like the normal distribution, because there are tools available to us today that use computational power, where you don't have to worry about all these things that people worried about in the 1920s when they didn't have access to computers and had to do all these calculations by hand. And that's something that we stress in our courses on statistical methods, that you should use these more modern methods instead, because usually they work as well if you have normal data, and they work better if you have non-normal data. So they are a good default choice in many cases. Okay, well, there are lots of other things I could show you here as well. I'd like to say a few words about this thing I mentioned about reproducible research, and also about how to store your results from R. Of course, you can write code like this, you can save it, and you can open it again and run it again, and you can reproduce the results that you got. But something that I like to do is to use a function here is called R Markdown, which lets me write entire manuscripts, if I like, or reports about my research or the project that I'm working on directly in R. So I can combine R code, use that to create figures and tables, and then export the results to Word or to HTML or a PDF file or something that I can then share with others. So I do this a lot in research when I write my reports and write up my results. And then I have a really good basis for presentations and papers and so on. So in R Markdown, you can mix regular text, the kind of text that you would write in a paper, with chunks of R code. So you can run some R code. In this case, I'm running some R code to create a density plot. Then you can have more text. You can maybe fit a regression model and print a summary table in a nicely formatted way, and so on and so on. So you can do all your analysis in these code chunks, run all that R code. You can choose to include it in your report or not. Maybe you just want to include the results. And then you can share it with others. You can write your entire paper in this way if you like. So this knit button here will let me export this report to different formats. Maybe I want it in HTML. Maybe I want to post it on my blog or something. So once I click that, R will run through all this code and then create a document showing the results, which will look like this. My research report was the title of this. First section is called data exploration. There's some text that I wrote. I chose to include my code so that it's clear what's happening to someone who knows R code. And the result of that code is printed as a figure. There's some more text, another section. Then there's a table with some values from a regression model that I fitted using the other code chunk, and so on. And this gives me nicely presented output from R in a format that I can easily share with others, or post on my blog or whatever I wanted to do. Of course, I can export it to Word as well if I wanted to. I can use different templates to make it look in different ways in Word as well. So here's my research report in Word. And I can, of course, share this with my collaborators, and they can continue working on the manuscript. I could use this as a starting point, or I could write the entire paper in our Markdown and then have it updated without having to worry about, copying in the new version of the figure, changing that value in the table. I don't have to worry about copy pasting numbers into tables or writing them by hand and getting the decimal point in the wrong place and so on. R will take care of all of this for me. So I think this is a really useful tool for researchers as well, the fact that you can combine R with writing reports and writing papers, and it's quite easy to do so. So what I've just shown you are some of the capabilities of R for visualization, for regression modeling, for reproducible research. And of course, there is so much more. There are packages for all kinds of things in statistics. So I'm basically sure that anything that you want to do, you can, in terms of data analysis, you can probably do it in R. So once again, I want to mention our online courses on statistics with R. I recommend starting with the introductory course, and then you can mix and match as you see fit between these other courses. Personally, I really like the visualization course, which is where we really get to explore the graphical capabilities of R, which I find really useful. Okay, so that's it from my side. I'll happily take your questions about R, about these courses, about whatever you have on your mind.
Okay, thank you, Måns, for the great presentation. I would just like to add that all these courses are updated and published on our web pages. So if you go, I think the easiest way is just to go to Alfasoft.com, our web pages, and click the training and events, and then click the R category. And I see we have added for the R1 course, we had added until all your courses until summer 22. And for the other, I think they are updated until February, March, but we will update also the other courses. So you will see them there.
Yeah.
Yep. We have some question here. One of the question is quite interesting. Is about the difficulty of R. As you can see, it's a programming language. But before you answer, Måns, I would like to add, you are using RStudio as the shell around the R programming package. There are also other shells, like we offer a shell called Blue Sky Statistics, which make R menu-driven. Like the Windows program you are used to, you can do most of the features and the statistical methods just by importing your data, and then via the menu functions choose the statistical method you wish, or your visualization you wished. So there are other options also, so just be aware of that. But Måns,
and I can add that that's a nice way to get into R as well, I think, to have menus that help you with the first steps. I think that's very useful.
Yeah, absolutely. And I know also by you using these menu-driven shells, you also see the code, so you learn a lot of code by just using it. So yeah, it's a nice introduction to this. But I don't know. Can you say anything about the difficulty of using R? I guess you will recommend the R1 course. So
yeah, definitely. I mean, that's a course that's intended for people with no background in programming. Of course, if you know programming, it doesn't hurt. It means that you will probably finish the materials faster, but it's constructed for people with no background in programming, so you're not assumed to be a programmer when you go into this. So for a lot of people, the big challenge is when you get into R is just to shift your mind into a sort of programming perspective and getting used to writing code, to the fact that the computer does exactly what you tells it to do. If you misspell something, then it won't work. That sort of thing is what most people find challenging. So 95% of the questions that I get in the R1 course turn out to be related to people misspelling things. So that's actually the main challenge. Once you see the examples that we have, it turns out that it's not that difficult to do these things, to transform your data, for instance, to create plots, because you always do it in the same way, basically. And there are a few basic things that you always want to do, and when you've done them a couple of times, you know how to do them. You can always go back to your code and copy that and reuse it. So it's really not that difficult. But the thing that takes getting used to is that you have to be really literal and get everything perfectly right. And becoming able to spot those spelling errors, for instance, is what takes people some time.
Yep. I see that the time is running out, but let's have a few questions here. There's a lot of questions coming in. To all of you who have asked questions, I will forward them to Mons, and he will answer them, and we will publish them and send them to you probably next week. So rest assured, we will do our best to provide you with the answers we can't answer today. It's an interesting question here about Python. Some people recommend Python instead of R for data analysis. What are your thoughts on that?
Yeah, so I get this a lot. People ask me this question a lot. And I think the people who recommend Python, which is another programming language for data analysis instead of R, usually come from a background in programming or data science. Sorry, not data science, computer science. And I think the reason for that is that Python is a general purpose programming language. It wasn't designed to do statistics originally, but it now has some statistics features. And for someone who already knows programming, maybe they know Python, so then it's convenient for them to use Python. But I'd say that if you want to do statistics, then R is just far superior to Python. It has many more methods, and it has them implemented in the right ways. Some very common methods you probably want to avoid using in Python, like logistic regression, for instance, where the default settings for the logistic regression function in Python actually are just terrible. You should never use them. So you have to do lots of manual tuning for those methods if you want to use them in Python. Python is really good if you're into machine learning and AI and want to work with that. But if you're more into statistics and statistical analysis or visualization or some data science things, then I highly recommend R instead, because it has better functions and is just more mature and safe to use with statistics.
Yes, we can do one more question. You mentioned that there are thousands of add-on packages for R. How do I know which ones to use?
You attend our courses? No, well, of course, in our courses we will teach you some of the most important and useful packages, because there are more than 17,000 packages. So obviously you're not going to use all of them. Not all of them are going to be relevant to you. But when you start discussing this with colleagues in your field who are using R, you'll learn that they are using some particular package that's very useful in your field or for the kind of data or models that you're working with. And you usually, through word of mouth, you learn about new methods. All new packages typically have blog posts or articles describing their usage, and you can read about them as they come and see what seems useful to you. So most of the time I discover new packages from just reading about what others are doing. I read an interesting analysis and see that they used a particular package, and then I can look that up. So you don't have to know about all of these. You will know about the most important ones after you finish our courses. And then as you get some special needs with some special kind of data or something, Google will help you find the right R packages for that purpose.
Thank you. Okay, I think we will have to stop there. There are, as I said, there are more questions here, but we will address them after this webinar. So yeah, Måns, thank you for the great presentation. I think Rob sums it all up here in the chat question window. That was the simplest and therefore the best introduction to R I have ever seen. So thank you, Måns. And thank you to all the attendees. We will be switching to our next webinar.